So before we look into the problems, let me just go ahead and talk about two major ratios that we're going to deal with. Number one, we would just talk about molar mass, right? Molar mass. It's all about the relationship between mass and quantity, and this quantity, it's in terms of the group, which we call it mole. Okay, that's one major ratio. The other ratio is your Avogadro's number. Okay, Avogadro's number, which is what? That somebody figured out, which I wrote earlier, that 1 mole of anything, it's equal to 6.022 times 10 to the 23rd of whatever thing that you would like to say. All right. Now, I intentionally put the blank right there because it is supposed to be a blank. It's like you have to insert a noun over there. Like by saying 1 pair, I would have no idea you are talking about 1 pair of what. You have to say, oh, it's about 1 pair of shoes, or 1 pair of socks, or 1 pair of glasses. You have to say it specifically. One thing that I've seen a whole lot is that students, when they see the word mole, they just presume that it is going to be about atoms. No. 1 mole of anything, it's 6.022 times 10 to the 23rd, that many individual anything. You want to say 1 mole of carbon, then there shall be that many carbon atoms. If you want to say, oh, I want to talk about potassium, then, well, then there'll be so many potassium atoms. And by the way, if you put those atoms on the scale, they would give you the mass differently because, they are made of different number of protons and neutrons. They, of course, shall give you different masses. So this whole unit, it's about your understanding of these two ratios, basically. Do you know when to use it, why you use it, and how you use it? And like I said, if you know how to do approximation, that would be very nice. So we start off with this question, okay? And I always like to ask a very simple question. You look at the number and you say, hey, how many moles? First, is it more than 1 mole or less than 1 mole? Yes, and how do you know? The power. I don't quite care about this, but the power tells us a whole lot. This is 10 to the 12th power. It's less than 10 to the 23rd. It's less. Well, it's a lot less. It's like 10 to the what? 10 to the 11th power order less. Okay, so what are we expecting right here? We're going to expect some kind of negative exponent, mole, right here. It's going to make you feel uncomfortable because there's an exponent, there's a small, tiny negative number right there, but it's okay because that's what it is. It's a tiny fraction of a group, okay? Not even half. By the way, I want you to understand that you may want to give this a thought, that when we say 1 mole, as I said, it's a group, right? And I want you to build this little image right there. A lot of individuals, okay? And if you say, oh, what about half of it? Well, half of it would be like 3.011 times 10 to the 23rd. Still 10 to the 23rd power. So if you say, oh, what about this amount of atoms? Then we're talking about like a tiny little fraction of a single group. And because of this, we shall know what to do with our numbers. Okay? We say, oh, where do we put the 6.022 times 10 to the 23rd? Should we put it in the numerator or should we put it in the denominator? It has to be denominator for 2 reasons. Okay? Well, your teacher's reason is that, well, we want mole, right? So we should have the mole number at the top. But my reason is, you know it's going to be less than 1 mole. If you put that 6.022 times 10 to the 23rd in the numerator, well, then you're going to get 10 to the 35th power. That's way more than 1 mole. Way, way more than 1 mole, and that makes no sense. And so I hope you understand what I mean by psychological right here. And that is, it's the appearance of the number that makes students feel uncomfortable. 10 to the negative 12 power. That would be the number of moles that we are having, a tiny little fraction of a mole. But now I got you the answer, okay? And I was going to ask you a second question. It could be a little bit too late, but I'm still going to ask it. My question was originally, should we use molar mass right here? Apparently no, but I would like to see if you can come up with a reasonable argument to talk to yourself and say, of course we don't use molar mass. Should we use molar mass for this calculation? And the reason no is, the reason for the no is, well, this question, it's asking how many groups there are. It mentions or it concerns nothing about mass. That's why, okay? Now, I also want to build a little mental thought process, and that is this. Now, it's going to be a bunch of if-then statement. And that's how you know you are very fluent with the ratio. Like I said earlier, with speed limit, if you know the distance, then you know the hours. If you know the individual or the number of, if you know the number of individuals, then you must know the number of moles. Okay? Just like if I give you 24 individual eggs, then you must know how many dozens of eggs. You must. Okay? Now, can we extend this question? Yes, of course. If we say, we would like to know the mass of the lead atoms right here, then we say, well, if we know the moles of lead, then we shall know the mass of lead. Because on the periodic table, we know the molar mass. So here's another blind spot that students don't know, is that the molar mass is always given on the periodic table. And by that, it means you will always know the mass if you know the number of moles, and vice versa. And vice versa. And the way to build your conceptual thinking is to have a bunch of if-then statements in your head. Do you do programming? No? Try it. It's good for you. Okay? Because with programming, it's just running all these logic tests. If this, then that. Good. Let's go ahead, try number 3.